Remember, we have three kinds of forms. We have standard form for quadratic equation. We have, excuse me. But, excuse me. We have ax squared plus bx plus c. We call the standard form. And we have another kind of form called vortex form. Sorry. Thank you. So completing the square basically change the standard form into the vortex form. All right, I want to bring this point. So, oh my goodness. Remember standard form, we have ax squared plus bx plus c equals 0, right? And the vortex form, we would want to solve a times x minus h squared plus k. In that case, so this is called a vortex form. You see, completing the square means we want to write ax squared plus bx plus c into the form of a times x minus a number square plus k. So in this case, h comma k is a vortex. Okay. Okay. So if anyone has any questions, feel free to stop me anytime. All right. So let's just review some basics, right? 2 times 2 equals 2 squared. So 2 times 2 we write as shorthand, 2 raised by 2. X times x, that's x squared. Right? X minus 1 times x minus 1, that's x minus 1 squared. Right? X minus 1 squared basically is x. It's just x squared minus 2x plus 1. Oh, no. It's another example. So we could have x squared minus 2x plus 1 squared, da, 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 da. Right? So we understand the square. A square is an algebraic expression multiplied by itself, right? Completing the squares. Let's see. If we have 3, 3 is not a square itself. But however, we can add 1, subtract 1. We add 0. That's fine, right? So 0 in this case is 1 minus 1. I like to call 0 and 1 transformers because 0 is any number subtract itself. Right? And the 1 is any number divides itself. We always use this trick in mathematics. We always add 0 multiplied by 1. We add 0. This 0 is any number subtract itself. In this case, this 0, we add 0. 0 is 1 minus 1. So 3 plus 1 is 4. Now we managed, right? We complete a square. So now a square appears. So 2 squared minus 1. And similarly, 5 we can write as a 2 squared plus 1. Right? If we have x squared minus 2x, you know, we can add 1, subtract 1. We can write as x minus 1 squared minus 1. So this process is called completing a square. If we have x squared minus 2x plus 3, we can separate 3 into 1 plus 2. Then x squared minus 2x plus 1, that's x minus 1 squared, then plus 2. Okay, let's see if when a equals 1, so this case is a equals 1, right? So we just have x squared plus bx plus c. Remember, we have perfect squares, right? A squared plus 2ab plus b squared. A minus b squared, that's a squared minus 2ab plus b squared. X plus 4 squared is x plus 4 times itself. It's x squared plus ax plus 16. X plus 5 squared, that's x squared plus 10x plus 25. Right, we see 2ab here, right? You see this multiplied by 2, 2ab. 2 times x times 5, that's 10x. A squared is x squared, b squared is 5 squared, 25. Right? 2ab, 2 times a, 2x, times b, 4x. Right? So this is x squared, this is 2 squared. X minus 3 squared, x squared minus 3 squared, 2 times x times minus 3, that's minus 6x. So let's see, in this case, what's the relationship, between those? If we have x plus minus s, right, that's x squared plus minus 2s times x plus s squared. We see in this case, b equals to 2s, right? Or s equals b divided by 2, and c equals s squared. So we're going to use this relation when we're completing squares. C is b over 2 squared. So let's see, we want to complete squares for this, right? X squared plus 6x. So what do? We divide 6x with 2. 6x we divided by 2, that's 3x. Of course, we multiply by 2, because this is 6x. We basically want to factor out 2 from 6x. So we factor out 2, we have 2 times 3 times x. We see x is from the first term, so the second term has to be 3 squared. 3 squared. 3 squared is 9. So that's why we add 9, subtract 9. In that case, x squared plus 6x plus 9 is x plus 3 squared. So we have completed our square. Anyone has any question for this? So basically, we take the number before x, we divide by 2, then we add the number square, subtract the number square. So this is the process. So then that becomes x squared plus bx equals x plus b divided by 2 squared minus b divided by 2 squared. Because we add b divided by 2 squared here, so we have to subtract it. Let's see some examples. We have x squared plus ax. So a divided by 2, that's 4. So we want to add 4 squared, subtract 4 squared. In this case, we just add 0 to the expression, so we didn't change anything. Now, this x squared plus ax plus 4 squared. So a is 2 times 4 times x. Right, so that needs to be x plus 4 squared minus 4 squared, which is 16. Anyone has any question? So this is the process of completing square. Oh, allergies. Right. If we have z squared minus 5z, well, 2 is not a factor of 5. So what do? We do the same. We take negative 5, we divide by 2, right? We add the square, subtract the square. Then right away we get this, because what is it? 5? 5 is 2, I'm going to change it, 2 times 5 over 2. Well, I should, if we change this to be addition, right? Let's just want. And we write this way. Z squared plus 2 times negative 5 divided by 2z plus negative 5 divided by 2 squared. So in this case, we get a perfect square. Then just subtract this number. And this number is just 25 over 4. Anyone has any questions? Let's see this example. The b squared minus 16b. Well, 16 can be written as 2 times 8, right? If you want to write negative number, we change this one to be plus. So that means b is negative 8. The second term, right? Negative b. So negative 16 divided by 2, that's negative 8. So that's b minus a squared minus negative a squared, which is 64. Anyone has any question? Pretty straightforward, right? Let's see the second part. Solve quadratic equations of this form equals 0 now, right? By completing square. So we have this. We have x squared plus 6x equals to 40. So before we could do it is we could put in a factored form. And this process is putting in a factored form. Then we factor out like this, right? Then using zero property, we get 4 and negative 10 as solution. But now let's try completing squares, right? Let's try completing square to see if we should get the same solution, 4 and negative 10. So completing squares, we only look at those two numbers, x squared plus 6x. Then we divide 6 with 2, so we get 3. That means we want to add 3 squared, subtract 3 squared, right? So we have this, x squared plus 6x plus 9 minus 9 equals to 40. And x squared plus 6x plus 9, we'll move this negative 9 to the other side, that becomes 49, right? And the 6x, so we could see this one. So I'm going to rewrite this one but one more time here. And we see 6 is 2 times 3 times x. And 9 is just 3 squared, right? So we have a squared plus 2ab plus b squared term form. Then this one gives us a perfect square. That's x plus 3 squared equals 49. Now let's square root both sides. Square root both sides. So we square root the left-hand side, we get x plus 3. Square root the right-hand side, we put a plus minus because negative number square also equal to positive. So when we square root, we give a positive value, we give a negative value, two values. Well, square root of 49 is 7, so we get a plus minus 7. Then we move 3 to the other side, right? So the first one, x equals 7 minus 3, which is 4. The second one is a 7, negative 7 minus 3, which equals a negative 10. Bingo, exactly as when we factored, right? So we get the same solution. Anyone has any question? Why 9 is still there? Uh, 9 minus 9. Hold on a second, let's see. 9 minus 9. Oh, you see, we started with this 2. We add a 0 to it, right? Because we want to have this 0, but we want to have this 9. But we cannot just add 9. We have to subtract 9. We can add 0 to the expression. Because we need this 9 to make a perfect square. X plus 3 squared. Is this your question? Otherwise, I don't have 9 minus 9. This is just a process of completing squares. You could have different thinking, all right? Because this one, I didn't move 40. I just keep 40, you know, 40 just stay put on the right-hand side. I'm just focusing on completing squares for those two terms. Okay, all right. So let's see this example. We have k squared minus 8 equals to negative 18k plus 88. So what do? Let's try to move everything to the left-hand side to factor it, right? So negative 88 indeed can be factored as those two, and then those two does add up to be 18. So bingo, that means this one can be factored as k minus 4, k plus 22 equals 0. So we solve, we get k equals to 4 and negative 22. Now let's try completing squares. Well, 18, I want to write one more term here. So k squared plus 18k, we can think 18 divided by 2 is 9. So we can write it as this. 2 times 9k, right? 2 times 9k. So that means, so I'm going to separate those two, okay? Actually, this, where does this from? It's from 9 squared. But then we have a minus 9 squared, right? We cannot just add 9 squared. So then this one becomes k plus 9 squared minus 81. Oops. Let's make sense of this. So I'm focusing on k squared plus 18k, right? And I want to change this one. I want to rewrite this one as a perfect square. So I read it as this way. Now we started with this. So what did we add? So listen, we started with this because the 88, right? Now so this one now can be written as this. So that means we can rewrite as k plus 9 squared minus 81 equals to 88. So then I move this negative 81 to the other side, that become plus 81. So 88 plus 81, that's 169. On the left hand side, I have k plus 9 squared. Now I can square root. When I square root, I get a plus minus square root of 169, which is 13. So that gives me k plus 9 equals to positive 13 and negative 13. If it were positive 13, I get k equals to 13 minus 9, which equals to 4. If it's a negative 13 minus 9 equals 22, I get negative 13 minus 9 equals negative 22. So I have the same two solutions. Anyone has any question? Right, we just focus on the square term and the k term. We divide by 2. We divide the coefficient of k by 2. 18 divided by 2, that's 9. So we just add 9 squared, subtract 9 squared. Well, let's see this one. Have z squared plus 12z equals 13, right? Or I could do this, right? I could move 13 to the other side. I have z squared plus 12z minus 13 equals 0. I can factor this. I get z equals 1 and negative 13. If we're completing squares, 12 divided by 2, I can write as 2 times 6z. But then I want to add 6 squared on both sides. 6 squared, 36. So when I do that, this one becomes z plus 6 squared. And 13 plus 36 becomes 49. Now I can square root both sides. I square root both sides. I calculate. I get it in the end. I get 1 and negative 13. Anyone has any question? Let's see this one. This one was given a factored form. However, the right-hand side is 45. It's not 0. If it was 0, we can solve right away. But it's not 0. So what do? We have to expand this. To expand that, we have c squared minus 3 plus minus 7. That's minus 10c. And negative 3 times negative 7. That's positive 21. Then we move 45 to the same side. That becomes negative 45. So now we have 0 in the right-hand side. So then they simplify to be c squared minus 10c minus 24. Well, minus 24 can be factored as positive 2 and negative 12. So I have two solutions for c, negative 2 and 12. So this is using factor, right? And you can use completing squares, right? If you use, let's try completing squares. Try completing square. So start with this. Then what do? We think we factor out negative 10. We factor out 2 from negative 10. So we've got 2 times 5, right? And because this is a negative 5, we could think, we don't really care. If we put a negative sign here, we don't really care the negative or positive, right? Then what do? Then we add 25, we subtract 25 at the same time. Now this part. So the first three terms becomes so I have c minus 5 squared, right? Then minus for 25 minus 24 is minus 49. Right, as minus 49. Then I can so 49, then I can square root both sides. When I square root both sides, I get c minus 5 equals to plus or minus square root 49, which is 7. Let's solve. I get a c equals to, if it's positive 7, 7 plus 5, that's 12. Or negative 7 plus 5, that's negative 2. So get two solutions, same solution, right? Negative 2 and 12. But this is called process of completing squares. Why are they adding and subtracting 25? Why they are adding and subtracting 25? Oh, you see this is 0, right? 25 minus 25 is 0. Why? Because we're completing squares. Negative 10 divided by 2, that's 5, negative 5. We add negative 5 squared, we we plus negative 5 square, and we minus negative 25 square. Does it make sense? This is the process of completing the squares. Why 25 minus 25? Because 25 minus 25 is 0. We can only add to the expression 0. You're not sure where 25 comes from? Okay, negative 10. Remember we have this term. We have, I think you missed it. Did you come late? We have this term, right? We said we just add and subtract b divided by 2 term. B divided by 2 squared. Add and subtract. So what's b here? B is negative 10. Negative 10 divided by 2, that's negative 5. So you could write as add negative 5, what's the minus 2 times 5? Because this is negative 10, right? Then you think, okay, what's 5 or negative 5 squared? That's 25. Then if you add a number, you have to subtract the same number to offset. Otherwise, you change the expression. Does it make sense? If you miss the first part, it may be a little bit difficult. All right. You can always go back to watch, all right? You can always go back to watch the class is recorded. Now let's see this example. We have x plus 7, x plus 9 equals 168, right? So what do? We can move negative, we can subtract 168 on both sides. So we get x squared plus 16x minus 105 equals 0. Then this one is factorable. We can factor it as plus 21 and minus 5. Or we can use completing squares. Okay. Or we complete a square. So how do we complete a square? Let's start from beginning. Right. So I have this. That gives us, I'm going to borrow from here. We expand this. 7 plus 9, 16. So we get the middle term 16x. 7 times 9, 63. Right. Do we really have to move 168? We don't really have to move 168 to the other side. We'll keep 168 on the other side. Okay. We'll keep like this. Okay. So now maybe we move 63 to the other side. So subtract 63 from both sides. (168 minus 63). 8 minus 3, that's 5, so that's 105. Right? Now let's complete square. How do we complete square? So 16 is 2 times 8. Right? What do? We just add a square, subtract a square. That means we add a square. Then we do the same, because we cannot just add a square to an expression or equation, right? We have to subtract, or we can add on both sides. Right? Since we have equation, we can add on both sides. All right, so the equation stays true. So this one, I cannot change the color. Otherwise, I like to change the color. You see, I focus on those two. I take the middle term 16, I divide by 2, that's 8. So 16 can be written as 2 times 8. And then I want to add a square, or subtract a square, or add a square on the other side, since I have an equation. Okay. So that means this side I can write as x plus 8 squared. Okay. So this is x plus, so the left hand side is x squared, x plus 8 squared. And the right hand side, 105 plus 63, what's that? 105 plus, not 63, 64, 169. 169. See, I complete square. Then I square root both sides. But if I square root the left hand side, I get x plus 8. If I square root the right hand side, I get a plus minus 2 values. 13. Because 169, square root of 169 is 13. Does it matter if you use addition or subtraction? Like, can it be negative 8 squared on both sides instead of 8 squared? Well, let's figure out. So we have a plus 16, right? That means this is a positive 8. We don't need to do negative 8. So this is also plus, right? But this one is a negative 10. So negative 10, well, we could think this plus negative 5. Then this will be negative 5 squared. Because it's a square, we doesn't care. Because negative 5 squared is still positive. Positive 5 squared is still positive 25. All right, so it depends. Depends. So we have this, right? We move 63 to the other side. Then 16 divided by 2, that's 8. So we change 16 to be 2 times 8. So we add a square on both sides of the equation. Now we have x plus 8 squared equals 169. We square root both sides. We get this. So x equals to positive 13 minus 8, which is 5. Negative 13 minus 8, which is negative 22, 21. Right, we have two solutions, and these two solutions is exactly same as when we do factoring. For x squared minus 10x plus minus 24 equals 0, why don't add 24 to the right? Hold on a second. Let's see. Okay, let's check this one. All right. So this one we start with c minus 3, c minus 7 equals 45. Right. So we simplify, so we get this. Why do we want to add 24 on both sides? I don't understand what you mean. Oh, okay, I understand you. I understand what you mean now. You are thinking, okay, from here, what we could do is, we don't do this way, we do this way. Do you mean this? Just subtract 25 on the left-hand side, same as you add 25 on the right-hand side of the equation. All right. Instead of saying that minus 49 equals 0, we can write that equals to 49. That's what you mean? It's the same. You add a number on one side, it's the same as you subtract the number on the other side of the equation. Equal, equal. All right, let me explain this. Okay, so if I subtract 25 here, that's exactly the same as, I'm going to write both of them, okay? You see these two equations exactly the same. Exactly the same. The first one, I just subtract 25 on the left-hand side. The second one, I add 25 on the right-hand side. They're exactly the same, okay? Okay, now, a is not 1 anymore. It's in general. In general, we have ax squared plus bx plus c. So what do? We can factor out a. Then the rest will be same as before. All right. Let's see this one. Now we have 2x squared minus 6x plus 15. So what do? We factor out 2 first. So we get 2 times parentheses x squared minus 3x. Now we focus on x squared minus 3x. But that's minus 3 divided by 2. Square is, which is 9 over 4. So what do? We add 9 over 4 and subtract 9 over 4. All right, as if we add 0. By doing so, we have a perfect square. We have x minus 3 over 2 squared. Then this negative 2 times negative 9 over 4 can move to the other side. Then when we add, we get 39 over 4. Then we square root both sides. So we get x minus 3 over 2 equals plus minus square root of 39 over 4. Well, square root of 4, just 2. So we get x equals to, we move negative 3 over 2 to the other side. We get x equals to 3 over 2 plus minus square root of 39 over 2. This one, we don't get the middle term as an even number. There's no factor for the middle term. So we get a fraction. And we call this irrational solutions because square root of 39 is just irrational number. Anyone has any questions for this? Okay, this is confusing, I know. So, okay, so we factor out 2, right? We factor out 2. Maybe we could do is, we could divide this 2, maybe to make it simpler, to divide by 2 on both sides. So if we divide by 2, oh, you know what? Let me keep this one. This is the same as, because the fractions makes people confused. So I have 15 divided by 2, right? I just divide by 2 on both sides. So I have x squared minus 3x equals 15 divided by 2. Now, remember how do we complete squares? We take the middle term, we divide by 2. So that means c, ax squared plus bx plus c, remove c, is this, negative 3 over. We take this number before x, we divide by 2. So that's negative 3 over 2. And that's why, so what is, when we square this number, what do we get? We get 9 over 4. Let's put divided by 2 on the other side. That'd be easier. Now does it make sense why we add 9 over 4, subtract 9 over 4 now? Okay, Kiana say yes. What about Zhou Hao? Does this make sense? Nope. All right. Which part is nope? Why is it so confusing? What about the previous one? Do you understand here? What have we done here? Yes, okay. So this now is exactly the same as before. So we started with this, right? The number before x squared is not 1 anymore. If you understand that those ones with 1, so what's the difference is this 2. So what do? We factor out this 2. Once we factor out, we divide both sides. Do you see this one is exactly the same as before now? Because the number before x squared is 1 now. It's exactly the same as before. Right? Now, what's b term in this case? Remember, we have x squared plus bx plus c. What's b? Negative 3, isn't it? We do b divided by 2, negative 3 divided by 2. Then we square it. Because we have a squared plus b squared. Mathematics is it's what do you call it? It's cumulative. If you have questions or you don't remember stuff before, it's going to be difficult. Nothing is going to make sense for you. Everything comes from before. Right? It's all from here, from this square term. You see this is 2ab, the middle term is 2ab. And in this case, you see the first term a is x, isn't it? A equals to x. So we're trying to figure out b. What's b? You see b is negative 3 over 2. Right, so this 3, so we want to write as adding 2 times negative 3 over 2. You see 2ab form? So x is a, 2 times a times b, ab. Does that make sense? Okay. Now you keep going. Now remember we want to add negative b. We want to add b squared. You see we have a squared, x squared. We have 2ab. We have 2ab. Now we're just missing b squared, right? Just missing b squared to make a plus b squared. So what do? We just add b squared. We could add on both sides, or we add on one side and subtract the same term. So we just add negative 3 over 2 square on the left-hand side and on the right-hand side. Right? Then what do we get? We get x minus, well, what's b? Negative 3 over 2, right? Negative 3 over 2 squared. So this one, this left-hand side becomes x a minus b squared, right? Or a plus negative number squared. Then the right-hand side becomes 15 over 2 plus 9 over 4. which is 39 over 4. Does it make sense? Then we square root both sides. Square root both sides. Get x minus 3 over 2 equals to plus minus square root of 39 over 2. It's exactly the same as before. Oh, actually we have here. Right? That's why we have, you know, here I add and then subtract. Well, you could add on both sides, exactly the same. Right? So we get x minus 3 over 2 squared equals this. Then we square root both sides. Does this make sense? Is any part still confusing? Let me delete something because I have something repeated. Right. Add and subtract on the same side or add on both sides of the equation. Okay, same thing. So we square root 15 over 2 as well. No, we combine them. Okay. You see, we have 15 over 2. Okay, hold on 1 second. Let me change this. 15 over 2. So we don't have this anymore. We have 15 over 2. 15 over 2 here, right? And then we don't have this. So 15 over 2. Now, this we move this one to the right-hand side. So add those. This is 4. We have to add those two. Oops. 15 over 2, we can write as 30 over 4. Then add 9 over 4, that becomes 39 over 4. Right? So we square root. Now we square root, right? So we write this one square with this. Then we square root. Square root, we get this. Square root, the other side, we get a plus minus 2 values. Then we move negative 3 over 2 to the other side. So x equals 2 values. One is 3 plus square root of 39 over 2. The other one is 3 over 2 minus square root of 39 over 2. Okay, any part is still confusing? This is also repeated. We don't need this one. It's the same as the previous line. You can see add and subtract on the same side, or you just add on both sides. Add this on both sides. It's the same. It means we don't write this one here on this side. We write it on the other side. Okay, nothing changes. Exactly the same. Then we don't need this one. Right? Add those two, get 39 over 4. How do I get x minus 3 over 2 squared? That's the step of completing squares. That's exactly why I figure out b equals negative 3 over 2. You see, all because of this. All because of this. I know the square is this, a squared plus 2ab plus b squared. So I need to figure out my 2b. What's my 2b, right? I have a squared here. A is x. What's b? The middle term has 2b in it. So this is the middle term. So this is negative 3x. Maybe I should write before this. So a equals to x, negative 3x equals to 2ab. Well, a is x, right? A is x. A is x. So this is x. This is x. That means 2b equals to negative 3. Or b equals to negative 3 over 2. I hope this makes sense. Everything, completing squares come from this formula, okay? From this perfect square formula. So then that's why you see, once I figure out my 2b, my b, so b is negative 3 over 2. So what do? I add b squared to make a perfect square. If I have this 3, that gives me a plus b squared. Does it make sense? The learning center has a tutoring session. Maybe make sure you schedule tutoring session. Maybe talk to a second person, because sometimes you talk to one person, it just doesn't make sense. Then you look for someone to help you, and maybe that make a better sense for you. All right. Okay, but do keep asking questions. Well, let's see more. Let's see this one. Well, 7z squared minus 14z equals to 9. So what do? We factor out the number before z squared. So factor out 7, right? So that becomes parentheses z squared minus 2z. Now let's divide it by 7 on both sides. Right? I think this way is easier for us. So we divide it by 7. Then we only have z squared. So let me do this later. So now I have z squared minus 2z. So I take negative 2 divided by 2. That gives me negative 1. So I know b is negative 1. Right? So negative 1 squared is just 1. So I'm going to add 1, subtract 1. All right, that's all the trick. That's the whole trick. What do? You take the number before z, the middle term, call this middle term. Remember x squared plus bx plus c. You take the number before the variable, not the variable square, right? Before the variable. So which is negative 2. You divide by 2. That's negative 1. Then you add negative 1 squared. Well, negative 1 squared is 1. Then you add 1, you subtract 1. You add 0, basically. Or you can add on both sides, right? Add on both sides. You add 1, subtract 1 on the same side is the same as you add 1 on both sides. Then this one becomes z minus 1 squared. And this one becomes, because 1 is 7 over 7. 9 plus 7, 16. 16 over 7. This square root both sides, right? Square root both sides. So square root cancel each other. So we have z minus 1. And square root of this one get plus minus 2 values. Square root of 16 is 4. So we get 2. So we move this negative 1 to the other side. We get z equals 2 values, right? Or we can write this way. 2 irrational solutions. Does this example make sense? Anyone has any questions? Anyone has any questions? Okay, let's see this one. Let's see more. Let's see more. See this example. Right? This example, there's only y. Right? So what do? We factor out. Confused with the last step. Okay. This step is this one or this one? Both. Yeah, I see you. We are towards. Okay. Anyway, so this step you're confused. The highlighted one. Where did we get this highlighted one? That's from this, right? That's exactly, why we did all this. We did all this because we know this one is this one, all right? And the 9/7, 1 is 7/7. Add together, that's 16/7. Square root. Square and square root, opposite operation. We square z minus 1, then we square root z minus 1, we get z minus 1 back. We square root of 16, we get 4. We square root of 7, we get square root of 7. When we square root, we have to write two values. One is positive, one is negative. Then we add 1 on both sides. So we get this one. Then 1 is 7/7. So we can write in this way too. Any questions? All right, let's see this example. 2y squared plus y equals 6. Right? We can factor out 2. Right? We factor out 2. Of course, this is showing, we can do factoring, do factoring. If we do factoring, we get a y, we get two solutions, y equals 3/2 and -2. But we want to use completing squares. Okay, so what do? We factor out 2. Oh, no, not divided by 2 yet. So from here, we factor out 2. If we factor out 2, 1y becomes half y, because 2 times half, that's 1, right? So then we divide by 2 on both sides. So when we divide by 2, we divide by 2 on both sides. 6 divided by 2 is 3. Now, again, we take the number before the variable, which is half. Then half divided by 2, which is 1/4. All right, so that's our B. So then we add 1/4 squared. So we figure out we take this half, we divide by 2, we get 1/4. Then we do quarter square, which is 1/16. We add 1/16, 1/16, or quarter square on both sides, right? Add quarter square on both sides. Okay, let's add on both sides. Then again, we know this is y plus quarter square. Right? Then we have 3 plus 1/16. 3 is 48 divided by 16. 3 can be written as 48 divided by 16. Because 16 times 3, that's 48. So 48 plus 1 is 49. So we get y plus quarter squared equals 49 over 16. Then we square root both sides. Okay. Square root cancel each other. So get a y plus quarter. Square root of 49 is 7. Square root of 16 is 4. So we get a plus minus 2 values. Then we subtract quarter on both sides. Subtract quarter on both sides. So we have plus minus 7 over 4 minus quarter. 7 over 4 minus quarter, that's 6 over 4, which is 3 over 2. Negative 7 over 4 minus 1 over 4, that's negative 8 over 4, which is negative 2. Two solutions, exactly the same as before. Any questions for this one? Okay, let's see next example. So I have a 4 here. Maybe we see 4 is a factor, 4 is a factor. This 4 is a factor. Let's see. Yes, 4 is a factor. So we can divide by 4. If 4 is a factor of every term, we just divide by 4. On both sides. Right. If we do that, we get this. So we get a y squared, negative 12 divided by 4, that's negative 3. And 112 divided by the 4, that's 28. We move to the other side, equals 0. And we can factor this, equal this. But let's complete in squares. Okay, let's try this method. So with this method, we want to write this equals to 28. Okay. Now, we think negative 3 over 2, right? Negative 3 divided by 2, that's that. Then we think about adding its square. Its square equals 9 over 4. Negative 3 is positive 9. 2 squares 4, right? So we just add. We add 9 over 4 on both sides. So we add 9 over 4 on the left-hand side. We add 9 over 4 on the right-hand side. And we know the left-hand side is, because we intentionally did this just for the purpose of making it a square, minus 3 over 2 squared. The left-hand side just becomes this. And then 28 times 4, what's 28 times 4? 28 times 4, 112. So this becomes 112 over 4 plus 9 over 4. Then it becomes 121 over 4, right? Because 112 plus 9, that's 121. So 121 over 4. Now square root both sides. Square root both sides. Square root cancel each other. So we get the left-hand side, we get a y minus 3 over 2. The right-hand side, we have plus minus 2 values. Oops. positive and negative. Square root of 121 is 11. Square root of 4 is 2. Right. We get a y minus 3 over 2 equals to positive and negative 11 over 2. This means two equations. If this is confusing, that means this. That means y minus 3 over 2 equals to negative 11 over 2. So two equations. We got two equations. Okay, because a negative number square is also positive. So when we square root, we'll always get a positive number and negative number. So the first one, y equals 11 over 2 plus 3 over 2, which is 14 over 2, which is 7. And the second one is negative 11 over 2 plus 3 over 2. That's negative 8 over 2, which is negative 4. We have two solutions. We have 7 and negative 4. Indeed, we have 7, negative 4. So that's how we're completing squares. Anyone has any question for this one? Should I give you one to try it? Or you want to try it on the homework on my open math? Can you revisit the plus 904 on both sides? Sure, of course. Okay. You mean this one, right? You mean this one? Okay. Okay, let me ask you this. How do you complete squares for this? What would you do? What would you do? It's all from the beginning, right? It's all from this. It's all from this. It's all from saying, okay, what is B here? B equals to, let me use the right color. It's all about figuring out the B. You see, we have a squared plus 2ab plus b squared. If we can form in this form, that's a plus b squared. So here we see we have a squared, right? And then we have a times 2b. This is a times 2b. Let's do this. So 2ab in this case equals to negative 3y. Oops. Let me use red color. Right? First is all from this, right? So we have a squared, and we don't have b squared, right? We're trying to figure out 2ab. So 2ab is the second term, 2ab is negative 3y. Negative 3y. And what's a? A is, let me write it here. For our case, a equals to y. Right? A equals y. You see we have a squared, right? 2ab is negative 3y. Two AB, so y is a, so that means 2b is negative 3. So hence b is negative 3 over 2. But then what's b squared? Oops. What's b squared? 9 over 4, right? The negative 3 squared is positive 9. 2 squared is 4, so that's b squared is 9 over 4. So you see here, we have a squared. Then let's write this one as a squared. Let's write as a plus 2 times negative 3 over 2 y plus, well, this is negative 3 over 2, negative 3 over 2 squared. Maybe this makes better sense. Negative 3 over 2 squared. Right? You say a is y, b is negative 3 over 2. So we have a squared plus 2ab plus b squared. And that is a plus b squared. That is y minus 3 over 2 squared. Does this make sense? Or anyone has any questions? Okay. Or anyone else has any questions? You missed the negative 3 over 2 square on both sides. So add, right, you could see add this number or add this. It's the same thing, right? Those two same thing. Oh, okay. All right. Okay, great. And anyone else has any questions? You just have to remember this. Remember this. This is a perfect square formula. Yeah. Just make sure you can do all the examples on your own. Then start your homework. All right. Okay, if you don't have questions, go ahead, start your homework. If you do have questions, I'm here. You're welcome. You're welcome. Are we going to have a review sheet before the final? There are review questions. They haven't opened yet. He's going to open on May something, beginning of May. Because this class is handled by the coordinator. I'm just, my job is just as like a tutoring. I don't have any control over the setups. You too have a good day. Study hard. Study. Thank you.